What if I told you there's a single, elegant principle that might just govern everything in our universe? Today, we're exploring a pretty radical framework that suggests exactly that. One simple rule that could connect the tiniest quantum particle to the mind-boggling vastness of the cosmos.
I mean, just think about that for a second. What if the universe isn't just a chaotic collection of random events and disconnected forces, but a giant interconnected system that's constantly, and I mean constantly, trying to find its balance? That's the core idea we're going to dive into.
You know, the search for a theory of everything is one of the absolute grandest quests in all of science. We've got these incredible theories, right? General relativity for massive things like planets and galaxies, and quantum mechanics for the teeny tiny stuff. But here's the problem. They don't really talk to each other. They just don't play nice, and that's left us with a kind of fragmented picture of reality.
But what if the answer isn't some ridiculously complicated new equation, but a much simpler, more fundamental principle? This is where the speculative idea of equilibrium mechanics comes into play. It proposes that at its heart, the universe is just a constant cosmic balancing act between two fundamental drives.
So first up, you have the expansive drive, which we'll just call E. This is basically the universe's tendency to spread its wings. It's the force of motion, of random change, of things spreading apart and getting more and more disordered. It's chaos, really.
And of course, pushing back against all that chaos is the integrative drive, or I. This is the complete opposite. It's the universe's tendency to pull inward, to bind together. Think of gravity pulling stars together, or atoms forming molecules. It's the force that creates structure and order out of that chaos.
Now, I know these ideas sound big and abstract, but they're actually grounded in concepts we're all pretty familiar with. That expansive drive, it's a lot like kinetic energy, or entropy, the scientific term for disorder. And the integrative drive, well, that's like potential energy, or the bonds that hold chemicals together. You can even see it in math, you know? It's like the relationship between differentiation, which is all about breaking things into smaller pieces, and integration, which is all about putting them back together.
Okay, so if you've got these two opposing forces in a constant tug-of-war, you obviously need a way to measure the tension, right? That's where something called disequilibrium, or CSE, comes in. It's super simple. It's just the difference between the expansion and the integration. If a system has a really high CSE, it means it's way out of balance.
And that brings us to maybe the most important new idea here, the balance index, or CEC. It's basically the flip side of disequilibrium. So when a system gets really close to being perfectly balanced, its disequilibrium, its CSE, gets close to zero, which means its balance index, the CEC, shoots way up. All you really need to remember is this. A high CEC means a system is super stable and likely to stick around for a long time.
So, how does this framework actually apply to the real world? Well, let's start with the big one, physics. Because this simple idea might just reframe some of the most famous equations in all of science. Okay, take a look at this. E equals mc squared. But wait, there's a crucial little addition there, the balance index, CEC. Now, the implication of this is just staggering. It's suggesting that the famous relationship between energy and mass isn't some fixed universal constant. Nope, it might actually depend entirely on how balanced a system is. Let's just break that down for a second. In this new view, energy is the imbalance of a system. Mass isn't some fundamental thing. It's something that emerges from how tightly a system is held together, its level of integration. And maybe the craziest part, even the speed of light, c, might not be a true constant, but more of an effective speed that changes depending on the local balance of the universe. Wild, right?
And if that wasn't enough to wrap your head around, the theory also suggests that the very fabric of space-time is tied to this balance. In regions that are highly stable, where that CEC number is really high, time itself could actually flow differently than in chaotic, unbalanced regions. This idea reshapes our most basic understanding of reality.
But this framework's ambition doesn't just stop with physics. Oh no. It claims it can help unify biology and even artificial intelligence. It's really trying to find one single rule that governs complexity, no matter the scale.
Let's take Darwin's theory of natural selection. We all learned about survival of the fittest, right? But this equilibrium view kind of flips the script. It suggests it's not really about the survival of the fittest, but more about the persistence of the balanced. Evolution stops being just a simple filter for survival and becomes more like a cosmic search algorithm that's always trying to maximize balance.
So here's how it would work. The expansive drive, That's your random genetic variation and mutations, all the new possibilities. Then the integrative drive, that's natural selection, comes in and preserves the forms that are stable and well-adapted. A successful species in this view isn't just fit, it's one that has achieved a really high CEC, a perfect balance between having enough diversity to adapt but enough stability to persist.
I mean, the sheer ambition here is just breathtaking. The framework suggests our brains work by balancing the flood of new sensory information against our internal models of the world. That when an AI learns, it's really just a process of minimizing its error, its disequilibrium, between what it predicts and what's real. It even proposes that the entire cosmos is just one grand balance between dark energy pushing everything apart and gravity pulling it all back together.
So the crucial point is, what does this all lead to? If this framework actually holds true, what's the ultimate takeaway? What's the new fundamental law it's proposing for the universe?
It all builds up to one single, powerful, and incredibly simple statement. A proposed first principle that could, potentially, sit right alongside the laws of motion and thermodynamics as a foundational truth of our reality.
Nature evolves to minimize disequilibrium. That's it. It's simple, it's elegant, and it's pretty profound. The core idea is that every single system, from a star to a living cell to a thought in your head, is driven by this one single imperative: find balance, because that's how you persist.
Now, of course, this is still a speculative framework, but it leaves us with a really provocative and compelling question to chew on. Is this constant dance between expansion and integration, this universal, relentless search for equilibrium, is that the deepest story our universe has to tell? Is balance the ultimate law?